Hey guys, before we get into talking about rational functions and graphing functions and asymptotes and all that stuff, first I just want to look at rational expressions and simplifying expressions. And then this will help us when we talk about equations and functions and all of that good stuff. So I've got some general rational expression rules. These are just expressions. Look at our examples. They're not equal to anything. We're not solving for anything. We're just trying to simplify. So to simplify means you're going to be factoring and reducing as much as you can. Now, when we say reduce, we're used to just saying, oh, there's an x plus 5 on the top and the bottom. I can cancel those out. Remember that cancel, just a friendly reminder here, cancel means that something divides to 1. Like x plus 1 divided by x plus 1 divides to 1. That's why we can cancel that. Or it could be that you divide to -1. We'll see some examples of that too. If you're adding and subtracting rational expressions, you need to make sure that you get a common denominator. So if you are setting up a common denominator, you're trying to figure out what is the least common multiple, or the LCM. What's the least common multiple? What's the least common denominator is another way to say that, but think of it as least common multiple for all the denominators present. We will talk about what that means as we get there. And then finally, complex fractions, which are fractions within fractions, those need to be rewritten and simplified. So we don't want to leave something as like with numbers, we would never leave something as 1/2 divided by 3/4. We would simplify that. And then finally, just for final answers, leave your denominators in factored form. And then numerators, I don't really care. They can be in factored form or general form. It just kind of depends on if it's worth factoring or not. So again, we will talk about all of this as we do some examples. We only have 6 examples to do. All right, so simplify each rational expression. Again, we are not solving, there's no equal sign, it's just reduce this fraction as much as possible. If I gave you 18/24, hopefully you would be just itching to reduce that. So what we do is factor each part. So I can factor the trinomial in the numerator, x plus 5 times x plus 5, or x plus 5 squared. I can factor the denominator, it's x plus 5 times x plus 4. We're looking to see what can divide out to 1. So you have an x plus 5 squared over an x plus 5. That means that you can take one set of x plus 5s and divide them out to 1. So I've got x plus 5 left in the numerator, x plus 4 left in the denominator. I don't need parentheses around those because they're not being multiplied by anything else. And that's it. That's my simplified expression. We could do a little domain piece like x can't equal -4, but we'll get into all that as we get further with functions. So this was just a simplifying problem, this single rational expression. Number 2 is an example of a division problem. So I'm noticing if I see a division problem, the first thing I like to do is flip or rewrite the second fraction. Remember, we don't divide by fractions, we multiply by reciprocals. So we could kind of do this. 4 minus x over, maybe we should factor this out. Part of the reason we've been doing all these factoring speed quizzes is because we're going to be using it a lot in this section. We did last section too. Trying to get 4x in the middle. So 4 and 1 is not going to work. I'm going to guess 2 and 2. And this is going to give me -6x plus 2x to be -4x in the middle. So the first fraction, all I've done is kind of factor things out. Change the division problem to a multiplication problem by flipping this fraction. So writing it as its reciprocal. Now the denominator was already factored, so that becomes the numerator. Leave that in factored form. Remember, you're trying to factor and cancel, so you never want to FOIL things together as your first step. 5x minus 20, you can factor a 5 out of that. All right, and I want to point out one more thing. 4 minus x and x minus 4. I want to be able to reduce as much as possible. If I left you with the fraction 4 over negative 4 over 4, let's do that. You would not just leave it like that. You would divide that to negative 1. Well, if we have 4 minus x minus 4, that's also always going to divide out to negative 1. You can test that by plugging in numbers for x, seeing if it works correctly. Or you could say, I'm going to factor a negative out of 4 minus x. That would make the x positive and the 4 negative. So that kind of reveals to you that you do actually have an x minus 4. It's just got a negative 1 on the outside, just like this has a 5 out in front. It was 5x minus 20. We factor the 5 out. That means that I can cancel a pair of x minus 4s, but the negative sign is still there. And I can also cancel or divide out the x minus 2s. Those divide out to 1. So what I have left, I'm going to leave my answer in fully factored form for this one. So I've got the negative sign. This x minus 4 is gone, which was this. I've got parentheses 7x minus 5. In the denominator, there's this 5 out here. I like to write the number coefficients first, and then 3x plus 2. This is a problem where I said numerators should be in general form or factored form. It does not matter to me if you distribute this negative through or not. There's no benefit to doing so. So I'm just going to leave my answer like that. And there's no benefit to distributing the 5 through either. The only time you would take time to do that is if you're looking for your answer on the AP exam in a multiple choice format and you see that they've done that. The next two problems are addition and subtraction. So remember, the rule for addition and subtraction is to set up a common denominator. And so the first thing we should be doing is looking at what these denominators are when they are factored out. So x squared minus 2x plus 1, that's x minus 1 squared. And we've got 3 times x plus 2. So the denominator for this one, if we're going for least common denominator, you need to have one of each factor represented. Like if I asked you to add together 2/3 plus, I don't know, 7/10. The least common denominator is 30, right? Between 3 and 10, or in other words, 3 times 2 times 5, 30. And remember, you multiply the 2 by what it's missing and the 7 by what it's missing to get up to that common denominator 30. And so same idea here. The common denominator needs to have one of each factor represented. So x minus 1 squared needs to be there. If this was an x minus 1, or yeah, if this were an 3 times x minus 1, x minus 1 squared is the least common multiple. Keep that in mind. Oh, and I'm noticing these 3's can cancel out, so make life a little bit easier for yourself. Instead of the common denominator being 3 times x minus 1 squared times x plus 2, the 3's can reduce. They're in the same fraction, so you're allowed to do that. So the common denominator is x minus 1 squared times x plus 2. Now, how do you set up the common denominator? Well, the first fraction has the x minus 1 squared, but to get the common denominator, you would have had to multiply it by x plus 2 over x plus 2. So you're going to have 2 times x plus 2. And then this denominator, 1 over x plus 2, has the x plus 2, was missing the x minus 1 squared, so we're going to have to multiply that into the top and the bottom. So plus 1 times x minus 1 squared, so that's just going to be x squared minus 2x plus 1. All right. Now, why did I distribute in the numerator? I just got done saying there's no real purpose to that. Well, when you're adding, you leave your denominator factored. You do need to distribute in the numerator because you're trying to add the fractions together, meaning like think about how we do it with numbers. 2 times 10 is 20, plus 7 times 3 is 21 over 30. If I add 2/3 plus 7/10, I do a bunch of work in the numerator to get 41 over 30. So same thing here. I need to do all of this work and see what it simplifies out to. So x squared, the 2x's cancel, plus 5 over, just leave this factored, x minus 1 squared, x plus 2. Another reason that we need to take the time to combine the numerators like that is because if you get something in the numerator that could factor and then reduce further with a factor in the denominator, then you would need to do that. X squared plus 5 can't be taken any further. We don't have one of those factors in the denominator, so that's as far as that goes. Number 4 is a fraction minus another fraction, rational expression minus another one, and their denominators are x minus 2 and x plus 3. So the common denominator is x minus 2 times x plus 3. We need one of each of those multiples represented to get the least common multiple. That means that the first fraction needed to get multiplied by x plus 3 in its denominator to get the common denominator, so we also have to do that in the numerator. So x plus 3 times x plus 1 is x squared plus 4x plus 3. The second fraction had the x plus 3, needed the x minus 2 to multiply in to get the common denominator, so we have to do the same on the top. Remember, common denominator, you learned this so long ago, what you're really doing is, again, we do this all the time, you're multiplying by a very special version of 1 so that you're not changing the value of whatever you're working with, but you're making it kind of work for you. And then here's a common thing to miss. You're distributing a negative x, not just an x, a negative x through those parentheses. So minus x squared plus 2x, because negative x times negative 2. It's that sign right there that's easy to miss. Every year, I don't know how else to stress this besides just keep practicing it, keep harping on it. We'll see how we do this year. But every year there's at least one person who keeps missing that. So we're going to try to work on that this year. What does this simplify out to? Well, the x squareds cancel. 4x plus 2x is 6x plus 3 over x minus 2, x plus 3. Now, I'm noticing that I can factor out a GCF. I can take out a 3 from 6x plus 3. Did I have to do that? I would not consider my final answer to be any more or less simplified than my previous step. So I would accept either one on a quiz or a test. The AP exam is not going to care. It might just come down to you finding which version of the answer is in multiple choice. If I can factor and it's easy to do so, then I usually do. But again, that's not the point. The point is, have we simplified this fraction so that there are no common factors left in the numerator and the denominator, and did we get it down to one single fraction from the original 2? Yes. Now, I left a bunch of space for problem number 5 because there are two methods for simplifying complex fractions. So this is complex.